Welcome everyone to another Sunday morning math session for the Victorian Selective School exam preparation, maths preparation exam, maths exam preparation lesson. Now, today we are going to extend our learning from the previous week. What we are going to cover is a bit of the coordinate geometry that we were doing. Uh, we'll talk a bit, we'll extend that a bit more on gradients, slope of the line, etc., etc. And then, if time permits, I will like you to learn today something called advanced factorization, which is roughly, if I were to map it to Victorian curriculum, it is a grade 9 topic. So if time permits, we will learn factorization uh, by grouping. We will learn some factorization of quadratic expressions. So let's get the ball rolling. Uh, Let me just share my whiteboard. All right, and my whiteboard's up and running. I say you cannot, don't edit it, guys. I don't like it. All right, cool. All right, 32 people have joined. Enough for us to kick off. All right, cool. Now, last week, what we learned were how to find the equations of the line using different forms. So we learned two different forms. First form was I call the slope intercept form, slope intercept form. So which was nothing but y equals to mx plus c. And the second form that we learned was, which was quite new to a lot of people, was point slope form. And that was y take away y1 equals to m times x take away x1. Now, today, what we are going to do is we will deep dive a bit more into straight lines, and we will see how different straight lines behave in different scenarios. All right, people are joining in. Okay, now, whenever you draw a straight line, uh, and let's say this is the Cartesian plane, x, y, negative x, and negative y. Let's say you've drawn a straight line. I'll probably, to show the straight line, I might change the color. Let's say first straight line is blue. That's the straight line. And let's say hypothetically, it is y equals to, y equals to x plus 1, for example. And let's say I draw another straight line on the same Cartesian plane, like this. And let's say this is y equals to negative x plus 5. Now, if you look at what's happening here, these two straight lines are intersecting at a point. Good morning, Shaban. So these two lines are intersecting at a point. They cut at one single point. Now, today we are going to determine how can we find that where this line intersects. So this line, wherever these two lines are intersecting, that's a coordinate. So what is the x coordinate? That's the x coordinate. And that's the y coordinate. So for example, hypothetically, I'm just making something up. This is not the right answer, just for the explanation purposes. Let's say this is 5 and this is 4. So these two lines are intersecting at point 5, 4. Now, graphically speaking, I can look at the two lines if they're presented to me in a graph, and I can tell you where the graphs are, where the two lines, straight lines, are intersecting. Let's look at it in in reality when everything's fall in place correctly. I'll just copy paste an image now. That'll give you more sense. I'm just going on to the next page now. So if you could hop on, it'll be great. I'll pull out a snippy uh, of a graph, which will clearly show you what I've just talked about. You see here. Here in this example, what you are seeing is there are two lines. I've got two lines. That's my first line, y equals to 4 minus x. And the other line, or the straight line, is y equals to 2x minus 5. And we can clearly see on the graph that they are intersecting at 3, x value is 3, and y value is 1. Now, till the time this is on the graph, it's absolutely fine. Let us say that I am not given this graph, and I'm just given the lines. That's about it. And I'm asked to find the intersection points of the two lines. So let's quickly go to the next page and try to find the intersection points of these two lines. So I'm just writing though the equation of the two lines again. Y equals to 4 minus x, and the other equation is y equals to 2x minus 5. Now, I am not given the graph. It's not graphically represented, but still I need to find the intersection point. I think my handwriting is improving with you guys. I'm getting better. All right. Now, I need to find the intersection point. So what do I do now? Have a very close look. Now, before you have a close look, if I say you A is equal to B, and I say A is equal to C, from these two equations, can I not say B equals to C? Can I say that? Or C equals to B? Now, if you look at the above lines, no, we don't need, no, Ara, we'll not draw any Cartesian plane. No, we're doing it, that's what we're learning here. We're not doing through Cartesian plane. We're just doing through plane algebra, okay? All right, so let's say this is A and this was B, and this is A again and this is B again. A equals to B and sorry, this is C, my bad. A equals to C. So can I say B is equal to C? Yes, I can. So I can simply say 4 minus x equals to 2x minus 5. Can I now quickly request you to solve for x now? Go ahead. Starting now, I give you 30 seconds. Go for it. Give me x. Value of x, Shaban. Give me the value of x. There are 38 kids here. It's not x plus 3, it's x equals to 3. I think that might be a typo. All right. Yes. So if you solve it, I mean, how do I solve it? Quickly, I'll say, okay, get me all the x's on one side and get me all the numbers on the other side. Leave me alone strategy. So I say, okay, I take positive 2x here, and I want to get rid of this 4, and I say, okay, a negative, positive, sorry, negative 2x, my bad, negative 2x, negative 2x, and I say a negative 4, a negative 4. This is gone. Eventually, x is equals, and this is gone, x is equals to 3. Now, when x is 3, what you need to now do is you plug in this x equals to 3 either here or here. Sub in x equals to 3 in y equals to 4 minus x. What do you get? X is 3, so you're plugging in x equals to, subbing it in, 4 minus 3, which is 1. So if you're using the first equation, you get y equals to 1. And hang on, you'll get the same answer if you plug it in here. Let's try. For y equals to 2x minus 5, plug in x equals to 3. So 2 times 3 minus 5 is still 1. So the answer that I got is 3, comma 1. And if you remember from the previous page, if I go back quickly, you see here, it was 3, comma 1, right? So this is quickly how you can find the intersection points of any two given lines without drawing them graphically. All right? Does it make sense, guys? Yes? If I may ask you now I'm going to the next page, please. I'm just putting two equations, and I want you to give me the x and y, right? So I say y, and obviously you will not have time to draw it, because if you'll draw it, it will take a lot of your time. Y equals to 3x, negative 3x plus 5. And the other equation is y equals to x minus 7. Can you give me the x and the y? Solve x, please. Good. 3 comma negative 4. I mean, I'll not go into this. Very, very simple. You just say negative 3x plus 5 equals to x minus 7. Right? And you find x equals to 3. X equals to whatever, 3. Plug back in, and you get y equals to negative 4. Easy peasy. All right. Now, another concept. Let's move on. Let's say I have a Cartesian plane again. And this time I have a straight line like this. And let's say I know the coordinates of the end points of the line. Let's say the end point, this coordinate is 1, comma 5. And I just say this is x, this is y, this is negative x, this is negative y. And I know this the first coordinate here, so I'm not scaling it, otherwise it will take a lot of time. And this is 4, comma 2. Yep, that's fine. 3, comma negative 4 is the right answer. Stop answering that. It's okay. Now what I'm interested in knowing is the midpoint. The midpoint of the line. So there are very key concepts that I'm just touching. You can practice, more, and I'll redirect it to you. I'll direct it to where you need to practice it from, right? Your parents will come to know in the WhatsApp group. All right, I now need to know the midpoint of the line. Now, how do I find the midpoint? Now, hear me out loud and clear. All right, the midpoint, so you see here, Mark the coordinates as x1, y1 and x2, y2. There's no guessing games here, right? We need to solve it. So this midpoint here, if you see, will have an x value, which I don't know what that is, and will have a y value, which I don't know what it is. So this x value, let's call it as x, is nothing but the average or the mean of the two x coordinates. So it will be x1 plus x2 over 2. You find the average. What is x1? 1. What is x2? 4. Divide by 2. So it is 5 on 2, which is nothing but 2.5. So this value, the x component of the coordinate is 2.5. It is very simple, Aradhana. If you have 2 points given to you, hear me out. If you have 2 points, just pick up the x values. In this scenario, the x value for the first point was 1 and the other one was 4. Just add them and divide by 2. You're just trying to find the middle. How do you find the middle? 2.5. You just divide the 2, you add the 2 and divide it. You add the 2 components and divide it by 2. That is precisely what I've just done. And similarly, you can find y. Pick up the y value. Aradhana, now you're going to do it right. 5. And the second coordinate is 2 over 2, which means 7 over 2, which is 3.5. So the midpoint is 2.5 comma 3.5. Yep, all good, making sense. I'm teaching from year 9 textbook, guys, so it's really, above your level, but the exam still expects you to do it. It's not difficult, right? Absolutely not difficult, especially when I'm teaching, I tell you. All right. Okay, cool. Now I'm just throwing 2 points at you, and I need the midpoint. Okay, so my x1, y1, and my x2, y2. Mind you, I'm giving you the formula as well, again, just in case you forget. x1 over 2 and y is y1 plus y2 over 2. Now, the points that we've got is 1 comma 0, and I give you 30 seconds to solve this. 1 comma 0, and the other point is 4 comma 4. Go for it. I need the midpoint. Good, good. That's the right answer. And mind you, you're not using calculator here. Not allowed. It is a crime to use calculator in these, right? Get over calculators, guys. You don't need it. All right, good, good. I'm keep throwing another one now. I'll change the color so that we make, some difference between the two questions. -3 comma -2, and I tell you, be cautious of the negatives, okay? 5 comma 3. Go for it. Absolutely right. 1 comma 0.5. Good, good, Shiva. Good, Shaban, Taha, Kartiki. Good, good. All of you. Great. Keep going. If you please solve it. Sarvesh, admin, good job. Throw more. Throw more. Anyone who's not done that? Anyone who's not understood that? Good, Sakita. All right, now, next concept. Good, Tarun. All right, next concept. Again, now, I'm drawing the Cartesian plane. And what I'm going to do now is, let's say that's my Cartesian plane. And good, everyone. Good, Aradhana. Praharsh. Okay, all right, hang on, stop. Now, let's say I have a Cartesian plane being drawn, and now I am asked to find, let's say I have this line. I'm just making something up. Let's say this point has a coordinate of 1, 3. This point has a coordinate of 5, not 5, maybe, let's say 7. 7, 4. Now, I need to find, now hear me out loud and clear. I need to find not the midpoint, I need to find the length of this line. How long is this line? So the formula to use the length of the line, I'm giving the formula straight away. Now again, mind you, you have x1, y1, and x2, y2. So the length of the line, or length, or I can also say the distance between the 2 points. Length or the distance between the 2 points. This formula is very important. So I call that distance as C, let's say, or D, whatever you want to call, right? So the distance D is a square root of x2 minus x1 whole square plus y2 minus y1 whole square. Yes, Laksha, that's a whole square, my dear boy, just not the y1, y2. Okay, that you've got a whole square on top. All right, so how does this play around? Let's quickly find how does this work. So what was my, someone's just joined. All right, my x2 is 7. So 7, always ensure the brackets are there. 7 minus 1 whole square. I've just subtracted the two x components plus y2, 4 take away 3 whole square. So if I solve it here, 7 plus take away 1 is 6 square plus 4 take away 3 is 1 square. So eventually you have 36 plus 1. So answer is root 37. So the distance of this line, or the distance between the two lines, is root 37, not 37 admin, root 37. There's a square root on top. Is this clear? Now, you can jumble it up. If I just go to the next page, because I think we've crammed it up a lot here. Going to the next page. So the distance formula can be written it like this. I think someone just wrote it like x1 minus x2 whole square plus y1 minus y2 whole square. Or you can also write it as x2 take away x1 whole square plus y2 take away y1 whole square. Always remember, if you're taking x1 before, then you take y1 before. If you're taking x2 before x1, then you take y2 before y1. Now I'm giving you, is this clear to everyone, right? Simple, straightforward, no dramas here. Straight application of the formula, all right? The distance formula is right in front of your eyes. I am now going to give you 2 points, and I am going to ask you to find the distance between the two lines, 2 points. All right. So point number one, x1, y1. Point number two, x2, y2. Let's see what it is. So the first point is negative 3, comma, mind you, there's a negative playing around now, okay? And the other point is negative 1, comma, 5. Go for it. Give me the distance between the 2 points. Good. Square root of 13. Good job. That means that made sense to you. All right, great. Any questions so far? Any questions so far? All right, now let's move on to the next topic. So I'm just covering key concepts and clarifying that out. It's up to you. Go back, revise it from the resources that I've shared. Good, good, Aradhana. Good, Kinetic, Karan, good. All of you right. Uh, straight application of the formula. You have 2 points and you just plug it into this formula or this formula. That's about it. Simple. All right, now let's go to the next page. Yes, thank you very much, admin. If you're enjoying it, I hope everyone's enjoying my lessons, right? All right, cool. The next one is, let us say I have a Cartesian plane again. Now, very important concept. Again, all right, enough of smileys. That's good, guys. But yes, concentrate, please. I love you all. All right. Okay. Now, let's say I have a line like this. And let's say the equation of this line is y equals to mx plus c1. M is the slope. Remember from the last week, M is the slope and C1 is the y-intercept. What was y-intercept? Where your line touches the y-axis. Simple. Now I'm going to draw another line. This line is parallel to the line, blue line. Now, obviously, this line is cutting the y-axis at a different point. So this must be C2 because they are y-intercepts. Look at these two lines. Don't you think that their slopes are exactly the same? Because they are parallel. When I say slope are same, that means the inclination is exactly the same. So the slope, the point I'm trying to make is that the slope of two parallel lines. So when I draw this arrow, so whenever in the question you see these arrows cross two lines, it simply tells us that the lines are parallel. And for parallel lines, the slope is Identical. Or identical might not be the right word. Equal. Slope is equal. So if I were to write the equation of this line, I will write it as y equals to, now since the slope of the first line was m, I cannot use anything else. Mx plus c1. So the slope of two lines are exactly the same. Now, how do we use it? Let us say I'm given two random equations. Y equals to 3x minus 4 and y equals to 3x plus 4. And I am asked that whether these lines are parallel or not. So what I'm going to do is I'll quickly just check, all right, 3 here, 3 here. And I'll say yes, they are parallel lines. Now, one word of caution. Your equations must be exactly in this form. So if I now, okay, I ask you a question now, right? I think I did ask you in the previous lesson as well. So if I have an equation like, let me make something up, negative 2x plus 3y equals to 5. Can you tell me what is the slope of this line? What is the slope of this line? Quick, that'll test your understanding from last week. Give me the slope of the line. Negative 10. You guys are kidding me or what? Okay, let's quickly check. All of you said negative 10. I mean, I'm just wondering how. I could be wrong. All right. See, now, all right, hang on. All of you are incorrect. Looks like either I'm incorrect or you. Let's quickly solve it and see. I could be wrong as well. Now, whenever you have to, now wait, now don't solve it now, okay? Don't solve it. In order to find the slope of the line, I don't think I'll be able to go to advanced algebra today because this topic is taking time. But then we'll see how it goes. All right, Tarun, don't worry about the others. Just concentrate on yourself. Forget about how many people on the before, on the previous page. You read in what page I am on. Finish about it. That's about it, right? Don't worry about the others. All right, cool. Now, I need to convert this equation that's given to me into this kind of a format. Yes, Nirvi, I think you might be right. 2 on 3 is the right answer. Let's quickly do it. What I need to do is, good job. You need to get this equation in the form of y equals to something. So which means make y a subject. So take everything away from y and leave y all alone. So what's sitting with y? A negative 2x. So I'll say a plus 2x, a plus 2x on both the sides. So 2x, 2x gone. So 3y equals to 2x plus 5. Now I need to get rid of this 3. So I divide this 3 across. So what I now get is y equals to 2 over 3x plus 5 over 3. So, my dear kids, the slope of the line is 2 over 3, not negative 10. I don't know how on earth did you say negative 10. Shaban admin, don't chat. Concentrate, please, right? You're disturbing me. So, y equals to 2 over 3x plus 5 over 3. So, my slope is 2 on 3. Guys, how on earth can it be negative 10? If you don't understand this, what I'm just teaching you will not make sense. That means you're not practicing. You're not practicing, right? All this effort is going in vain, all right? And I don't like it. All right. I need you to study, right? Your parents are spending so much time, money, energy, everything. Yeah, you need to perform, right? Oh, good. I'm throwing one more stuff at you. And now I need the right answer, guys. Okay? I need the right answer. I'm just making something up. 5x, be very careful what I'm writing down, minus 15y equals to 1. Can you give me the slope, the m? Convert this into y equals to mx plus c. 1 on 3, negative 1 on 3, Zara says negative, admin says negative 1 on 3, rhythm says negative, Taha says negative, da 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 da. Let's quickly have a look. A few of you said positive 1 on 3. All right, hang on. Sakita, Tarun, okay. All right, let's find it out what it is. I tell you, in mathematics, the biggest criminal is negative. The way why I'm saying that is because that negative means subtracting. So negative can actually subtract your marks if you're not careful. So you need to focus, right? Let's see what it is. Now I want to do y equals to mx plus c. All right, I've got 5x. I'm just solving it quickly, right? Just be with me. I have a 5x here. I'll say negative 5x, negative 5x. Sorry, a negative 5x, a negative 5x. So it is negative 15y equals to negative 5x minus 1. Now I have a negative 15 sitting with y. So I will say divided by, and I'll change the color. The color did not change. Negative 15 here, negative 15 here, and a negative 15 here. Gone. Y equals to, this is 1, this is 3, negative, negative makes it a positive. A positive 1 on 3x and a positive 1 on 15. So my slope is 1 on 3, not negative 1 on 3. All of you who have given me answer negative 1 on 3 need more practice. Okay? This one negative means one mark is negative from your exam. Finish. And that is the difference between top 10% who clear the exam versus the 90% who don't. There's nothing to be confused here, Tarun. It's all just negatives playing around. That's about it. All right? Now don't throw that smileys as well, right? Okay. Let's quickly go back to what we were learning. So, Tarun, just to sort of quickly give you another gist. So negative 5x on negative 15, what would that make? Negative, negative makes it a positive. So positive 5 on 15, which is positive 1 on 3. That's what we've done. That's about it, right? Nothing else. All right, now I'm throwing another concept here, right? I don't think I'm going to go into the advanced algebra today. I think that will be the last topic for the next week, which will be our last lesson for the term. All right, let's go to the next page. All right, now I'm just giving you a formula. I'm giving you a formula. All right, hear me out loud and clear now. Can you tell me before I quickly start, what exactly the word perpendicular means? Perpendicular. Or have you heard of the word perpendicular lines? What does perpendicular line mean? Have you? I am not exactly. Thank you very much, Karan. Yes, the lines that I've drawn. Good job. The lines that cross at the 90-degree angle. Absolutely right. Yes, Shaban, the lines that I've drawn. No, Shavin. It's not the line that cross at one point. The lines where, no, they're not parallel lines, Arif. Come on. You've changed the concept here. Now, all right. Perpendicular line means the lines that make a 90-degree angle with each other. So here, the x-axis and the y-axis are perpendicular to each other. All right? So they meet at one point, and that point and the angle that they make between each other is 90 degrees. All right. Now let's draw two lines here. A red line and a blue line. Look at the angle that they're making with each other. They're making a 90-degree angle. They're perpendicular. Now, if I were to, let's say, the red line has y equals to m1x plus c1. Now, the slope of the red line is very different from the slope of the blue line. So that is why I've called the slope of the red line as m1. And the blue line, let's say that blue line has an equation y equals to m2x plus c2. Now, the formula that I'm giving you now is very, very important. So when you have two lines which are perpendicular to each other, the product of their slope is always -1. Just remember that. When you multiply their slopes, you will get a -1. Now, let's quickly see how this can be applied, right? Let me just find out something useful for you. All right. Okay. Let us say I have the slope of a line m1 as 2 and the slope of other line m2 as -half. So hypothetically, if I create an equation of this line, I say y equals to -half x plus 10. I'm just making something up. And here I have y equals to 2x plus 7. Now, the slope of the first line is -half. You see here. And the slope of the other line is 2, which is here. Let's multiply their slopes and see what do we get. m1 times m2. 2 times -half. So the answer is 2 cancels. Answer is -1. So when the answer is -1, that proves, this is a proof, that the two lines are perpendicular. Now, let's see how we'll use it. Let's go to the next page. Let us say I'm just giving you two lines now, okay? And I'm testing you on exactly the same concept of ensuring that you find the slope first and then give me the proof. I'm just making something up from my mind, right? All hypothetical. 3x plus 2y equals to 1. That's my first line. And negative 2x plus 3y equals to 5. Can you prove me that these two lines are perpendicular or not? So which means you need to find the slope of this line. You need to find the slope of this line. And how do you find the slope of this line? The way we did it right before. Rearrange them in y equals to mx plus c form, both of them. And then pick up their slopes and then prove me that if m1 cross m2 is giving you negative 1, which means that will prove that yes, they are perpendicular. So in the answers, you just need to tell me yes or no, whether they are perpendicular or not perpendicular. So I need the answer as yes or no. Don't worry, Karan, if you don't understand, I'll do it. Let's do this one, right? So just Karan, can you just rearrange them into y, making y as subject? Can you rearrange them into y equals to mx plus c form quickly? Can you do that? That's fine, Shareen, whether they're perpendicular or not. I just made them up. Just made them up on the fly. Okay, a lot of you are saying not perpendicular. Okay, let's try. Let's rearrange the first one. Yeah, rearrangement is very important. So if I were to rearrange the first one in the red, I will say 2y equals to negative 3x plus 1, which means y equals to negative 3 on 2 x plus 1. So your slope of the first line is negative 3 on 2. Let's pick up the second line and I'll change the color. I'll say 3y equals to 2x plus 5. So y equals to 2 on 3x plus 5 on 3. So this was my M1. So my M2 is 2 on 3. Let's do M1 times M2 and I'll change the color again. M1 times M2. Is everyone clear how I found M1 and M2? Yes or no? Quick. Because if this is not clear, you cannot do this question ahead. You're gone. All right. Let's do M1 times M2. Negative 3 on 2 times 2 on 3. It is negative 1, guys. How on earth did you say that this is not perpendicular? Come on. I found it. You need practice. Practice, practice, practice. A hell lot of practice. You're just throwing something in the air or you're too busy doing it too quickly, right? 3, 3 gone, 2, 2 gone. I get a negative 1, guys. Come on. Either you guys are busy chatting or you're not concentrating or you're not understood, right? One of the three. Or you're too fast. Maybe could be 4. Did you get it? What I just explained. Did you get it? Right? This is year 9. And if you're a year 4, 5, 6, 7, and you're understanding it, good job. But you need to be careful with your rearrangement. I tell you what I've seen in the last 2 lessons is that you guys are okay with basic stuff. When your rearrangement of algebraic expressions, equations is where you're fumbling, right? That's your weak point, and that's not your weak point. 99% of the herd, that's the weak point. All right. Shall we try a question which is even more advanced than this, right? So ensure that all the pores of your brain are open still in the last 6 minutes, okay? And especially the people who are chatting. I mean, probably I can't do anything about you guys. All right, now let me throw something at you and see where you land. There is no point feeling sorry. You should feel sorry for yourself, guys. You're harming yourself not concentrating, right? On a Sunday morning, a lot of people have sacrificed their Sunday morning to come to these lessons. All right, the question is right in front of your eyes. Last question of the day, hopefully. And I want you to solve it starting now. Go ahead. That wraps it up. If you don't know how to solve this, I'm more than happy to see in the chat that I don't know. Good, Shaban, you've cracked it. That's the right answer. Admin, that's the right answer. Good. Y equals to 3x plus 4, not equals to. Yes, Shavin, right answer. All right, now I'm going to explain it to who've not understood it. Last question of the day. Hear me out very loud and clear without chatting. All right? I need to find the equation of a line which is parallel to a given line. So what they're asking me to do is that there's a Cartesian plane. Visualize this first. There's a Cartesian plane, and let's say you've got a line like this. This line is y equals to 3x minus 1. I need to find the equation of the line which is parallel to this line that I've just drawn, passing through the point 0, 4. Where is 0, 4? I mean, let's say if I were to scale it, hypothetically. So that's 0. So 1, 2, 3, 4. That must be 4. So I need to find the equation of, I'll just draw it in red. Equation of this line, which is parallel to this line. Is the first step clear? I need to see quickly. We've got 2 more minutes. Say yes or no. Go for it. Right? You need to understand the question first, right? If you can't visualize the question, you can't solve it. Now, next. I told you, now stop. Equation of the line is represented by y equals to mx plus c. I need to, if I find m and if I find c, job done. I got my line. Now, the line is parallel. And I told you for parallel lines, the slopes are equal. Slopes are equal. Now, I want you to quickly tell me on chat, this line, y equals to 3x minus 1. What is the slope? Quick, 10 seconds now. All of you, get your fingers warmed up, quick. All right, thank you. Just once. So slope of this line is 3. Shaban, you're just spamming it now, all right? Slope is 3. So y equals to mx. So this line must have the same slope because it is parallel. 3x plus c. So my first unknown is solved. I now know that this line, the red line, is y equals to 3x plus c. Now I am given another information that this line passes through this point 0, 4. Plug 0, comma 4 here. X equals to 0 and y equals to 4. Let's do it. Y is 4, x is 0 plus c. 3 times 0 makes it a 0. That means 4 equals to c, which means c equals to 4. So finally, this line which is parallel is y equals to 3x plus 4. It was that simple, Karan. Yes. When I explain it, it is the simplest explanation in the world. All right, guys, with this, we finish our lesson today. And I hope you enjoyed this lesson as always. Yes, it was magic. Thank you very much. I love you all, and I love your commitment here. I hope to see you back next Sunday. And next Sunday, be prepared. We are going to do advanced, super advanced algebra. Okay? We're going to touch quadratic equations, factorization, solving null factor law, blah, blah, blah. We'll try. And next week will be the last lesson for term 4, right? Before we say goodbye to each other. All right, cool. Thank you very much. And I will see you back next week. Enjoy rest of your day. Thank you.